Alright, this is chapter 25, problem number 5. The problem reads, two plane mirrors are separated by 120 degrees, as the drawing illustrates. If a ray strikes mirror M1 at 65 degree angle of incidence, at what angle theta does it leave mirror M2? So here we have the same drawing from the book for this problem, but just to make it a little bit easier, I substituted all the angle values for variables A, B, C, D, and theta, respectively. And as we know, we're going to be solving for this theta here. Actually, both of these thetas. But to start, they let us know that our initial angle of incidence is 65 degrees, so that's going to be our angle A. So we know angle A is 65 degrees. The angle A and angle B are congruent angles, so they have to be equal. So angle B is also 65 degrees. And once we get to angle C, angle B and angle C are actually complementary angles. So to solve for angle C, we simply take the 90 degrees that angle B and C make up together and subtract angle B, which we know is 65 degrees, from 90 to get our angle C, which is 35 degrees. And to solve for angle D here, we have to recognize that angles CD and this 120 here actually make up a triangle. And we know that there are a total of 180 degrees in the triangle, so to solve for the unknown angle, we simply take the 180 degrees that are in the triangle and subtract from it the 120 degrees given here and our C value, which is 35 degrees, to get a total of 35 degrees for angle D. And lastly, to solve for theta, we can see that angle theta and angle D actually are complementary, so their sum must be 90 degrees. So to solve for the value of angle theta, we simply take the 90 degrees that angle theta and angle D make up together, and to subtract angle D, which we learned was 35 degrees from it, to get the difference, which would be our angle theta, which is 55 degrees. And as you see here, where it would actually be coming off, these two angles here would be congruent. So the angle of refraction, which is what the problem asked for, would also be 55 degrees.